Okay, so 3.3 is on best practices and proofs. Okay, what are some things that we should know about in order to write a good proof? Okay, so let's look at what's allowed. Allowed assumptions and proofs. Allowed assumptions and proofs. Okay, what's allowed? One, any of the rules for algebra. The rules of algebra are always allowed. Okay, what else is allowed? The set of integers is closed. Get to what that means in a second. Is closed under addition, multiplication, and subtraction. But not division. It's not closed under division. We'll talk about why in a second here. Okay, what does it mean to be closed? What it means to be closed is that if you start off in the integers, you end up back in the integers. That's what it means to be closed. It means that you have a closed set. You don't have to go outside the set in order to do these operations. Z is closed under addition, multiplication, and subtraction. It is closed. It means that if I add two integers, I get an integer. If I subtract two integers, I get an integer. And if I multiply two integers, I get an integer. Now, why is it not closed under division? It's not closed under division because we actually have to go to the rational numbers. We actually have to go to Q to, or the rational numbers to do division, because division is x over y. And if both of these are integers, like 1 over 3, well, 1/3 is not an integer, it's a fraction. Okay, but so 1/3 actually goes to Q, not Z. So it's not closed under division. Okay, but we can assume that Z is closed under addition, multiplication, and subtraction. Okay, number 3, we can assume that every integer is either even or odd. Okay, we can assume the order of any two real numbers. Okay, the idea that there is something that is smaller or larger exists. Okay, and we can assume that the square of any real number is greater than or equal to 0. Okay, is non-negative. Okay. So terminology. Let's look at some terminology. Okay. Common keywords and phrases in proofs. Okay, common keywords and phrases in proofs. Okay, thus and therefore are used an awful lot. Okay, it follows. Okay, then, hence. Okay, these all mean, okay, we could maybe even say implies. Okay. Okay, this is a statement that follows from one or more previous statements. Okay, thus and therefore it follows, then, hence, implies. Okay, let, the word let. Okay, used for introducing new variables. Okay, for example, let x be a positive integer. Okay, so we're telling what is the new variable? What's the characteristic of the new variable that we're introducing? Okay, suppose. Okay, suppose can be used to introduce a new variable or statement. Okay, or statement, or we could say or assumption. Something that is assumed to be true. Okay, since is like building a bridge. Okay, this is used when a statement is derived from a previously stated fact. From a previously stated fact. Hmm. The phrase "we will prove" or "we will show," okay, indicates where the proof is heading. Kind of foreshadowing where the proof is heading. Hmm. By definition. Okay, used to a fact is known from a definition. Okay, used to state a fact. Okay, or an axiom. Okay, another word for fact, axiom. We just take it, we take certain things at face value that they're true. Okay, a right angle is 90 degrees. Okay, that's just an axiom. That's we can't really prove that statement. We just set it up that it is. The definition of a right angle is a 90-degree angle, and a 90-degree angle is the right angle. And that's just an axiom. That's just those are the building blocks for our proofs. Okay, it's used to state a fact, axiom. Okay, okay, from a definition. Okay, in other words, it's used to rephrase a statement in a more specific way. In other words, and gives or yields used as a bridge from one equation or inequality to another one. To another one. Okay, this gives or this yields, or we could say, simplifying yields this, or obtains. We could even say obtain. Okay. Okay, best practices. And proofwriting. You want to write a proof like the pros? Follow these five guidelines. Number one, indicate when the proof starts and stops using proof, colon, and a square. Okay. Number two, write proofs in complete sentences. Start with facts given or assumed. Number three, give readers a roadmap of what has been shown, what is assumed, what is assumed, and where the proof is going. Number four, introduce each new variable when the variable is used for the first time. And five, introduce a block of equations using a statement line up equal signs or inequalities. Okay. That's how they'll know you're a professional. If you line up your equal signs or your inequalities, it's very good. Very good. Okay, and justify each step. Give yourself a justification. Each step that does not follow from simple algebra. Okay. And if you follow these guidelines, you'll be writing proofs like a pro in no time. Okay, existential instantiation. Okay, is a rule that says an object can be given a name as long as that name is unique to the object alone. Okay, it's unique to that object only. Okay. Okay, common mistakes. Okay, common mistakes in proofs. Okay, number one, generalizing from examples. Okay, just because a property holds for some elements does not mean it holds for all elements. Some elements, I should say, of a set. Does not mean it holds for all the elements of that set. Okay. Number two, skipping steps. Okay, do not skip steps. Number three, circular reasoning. I'm going to prove this car is a Honda. Because it's a Honda, it is a car. Circular reasoning. I'm going to prove that the car is a Honda. I'm going to prove the Honda is a car. Well, not necessarily. Honda could make different things other than cars. So you're using circular reasoning there, and it will get you into trouble. Not all cars are Hondas, and not all Hondas are cars. Circular reasoning. Using what is to be proved as a step in the proof. That's not good. That's illogical. Okay, assuming facts are true that have yet to be proven. Again, not good. Okay. So some things to do and some things to not do. Okay, and that is section 3.3.